Hello everyone. So today in this video I'm gonna show you how to make an eccentric or non-axisymmetric geometry in ICEM CFD by reading the coordinate points from an user-defined text file. For the purpose of demonstration, I will uh, explain the process by making an geometry or making a cylinder which has an eccentric bulge in it, which looks like this. So there will be bulbs in it, but the bulbs would be not, it won't be axisymmetric. So for that, before we start the process, we need to have a text file which specifies the coordinate points on the surface of these geometries. Let's say these are the coordinate points and we have to specify them in a text file. We need to have a lot of coordinate points, and those particular coordinate points has to be arranged in a particular manner so that ICM CFD can understand. First of all, let's see the text file. Here I have a text file, and please leave the first line, first row. Apart from them, as you can see, these are all coordinates. These are the 3 xyz coordinates. Now we can't just arrange these coordinates randomly. These coordinate points have to be arranged in a particular order, and this is where the two numbers in the first row come into picture. The second number 37 represents how many curves can be made out of these coordinate points. The first number 78 signifies how many coordinate points goes into making of a single curve. This is important because in order to make the surface of the geometry, ICM CFD requires a lot of curves that aligns perfectly with the surface of the geometry. So the coordinate points, those are arranged in this text file, are as follows. The first 78 coordinate points are used to make the first curve. The next 78 coordinate points are used to make the second curve, and so on and so forth. So in total there would be 37 curves that would be made from these coordinate points, and these 37 curves lies at an angle of 10 degrees, and it encompasses the whole surface of the geometry, that is whole 360-degree. It will be clear once we import this text file into ICM CFD. So let's do that. So here is ICM CFD, and we have to import that coordinate points by going to import geometry, and we have to select formatted point data. Once you select formatted point data, we have to go to the place where we have already saved our coordinate points. So here is the text file. I have named it coordinates. Just click it and open. And don't forget to check these points. We have to import surface, curves and points, and I will explain why you have to check all those points. Now once you click apply, we have the geometry here. So how does it work? ICM CFD has the capability to make a curve by joining a number of coordinate points. So the coordinate points that were in the text file, those were used to make these curves. But how does ICM CFD knows which particular coordinate points constitute or come together to make one particular curve? So here, as you can see, there are a number of curves which makes the geometry. So there comes the 2 number at the top. So the coordinate points has to be arranged in such a way that the first 78 coordinate points makes the first curve. The next 78 coordinate points makes the second curve. So in total there would be 78 into 37 coordinate points, which means there would be 37, which means ICEM CFD can make 37 curves from all these points. So once we have imported the coordinate points, so ICEM CFD uses those coordinate points to make the curve. And if we also check the import surface option, ICEM CFD further creates a surface by combining all those curves. So here we don't just have points, we also have curves, and ICEM CFD has automatically connected those curves to make the surface. However, in order to make it usable for a let's say for a CFD simulation, we also need to have surfaces at this. Let's say this is the inlet, or let's say this is the outlet of a particular pipe or a geometry, but that's not already present here. So we have to make the surface here and also here, and for that we need to create a curve at the entrance. As of now, as you can see, the curves are only on the surface of the geometry but not at the inlet. So we have to create a curve at the inlet, then using that curve we can make a surface. In order to make a curve, first of all we need to assign a coordinate point at the center of the inlet, and I know these coordinates, and you will also know it if you happen to yourself make the text file. So that's it, and this will produce a point at the center of the inlet. Similarly, we will have to make a point at the outlet somewhere here, and in this particular case this is 0.07, 0 and 0. Once you click apply, we have this lighter blue color point at the outlet. Now once we have this point and the points on the edge of the circle, we can use them to make a curve at the inlet and the outlet. So let's make it. So after you have inserted these two additional points into the geometry, we have to make the circular curve at the entrance. So for that we have to select this circle from an arc of a center, and you just have to select the center, which is a light blue, and 2 points on the circumference of the circle. Let's select these 2 points, and here we have a curve. Okay, then at the outlet we have to repeat the same process. We have to select the center of the circle and 2 points on the circumference of the curves, and it's done. So we have 2 additional curves now, apart from all the curves which lie on the surface of the geometry. Now we make this inlet surface. For that we have to select the create or modify surface, select simple surface, and the method should be from curves, and you have to select the curve. Let's select this curve at the entrance. Once you do it, we have actually produced a surface which is not visible unless we check this box. Now once we have checked this box, the surface is visible. Now let's make the points disappear. Next we have to make another surface at the outlet, and for that we have to once again select the curve at the, not this one, the outlet, and press the wheel button to create the surface. Now we have the surface encompassing the full geometry. However, it won't be sufficient to just have the surface of the geometry. In order to use it for, let's say, CFD simulation, in order to discretize the domain, we need to have the inner body of the geometry, which will be inside the surface that we have just created. And for that, we can create the inner body by using this tab, which is the create body tab, and we can name it fluid if we want to use it for, let's say, fluid simulation. And it says that we have to select two screen locations, and the reason between these two screen locations would be the body of the geometry. And we can do that. First of all, you have to enable the points. This is the first point, sorry, the blue one, the light blue one should be the first point, and the other one has the second point. So once we have selected these 2 points, just click the middle mouse button, the wheel button, and we have a body. And of course, the geometry and the body that we just created has to be and the domain of this geometry has to be discretized, so that we can import it to other CFD solvers and use it. And discretization of these geometries, of cylindrical geometries, there are a number of useful YouTube videos. I will put the link to one such videos on the description. And that's all for today. Thank you.